Hey Year 11s, welcome to the video on today's lesson, which is generating arithmetic sequences and recurrence relations. So we're going to cover what recurrence relations are, what the rule is, how to find it, and how to write a sequence using the rule. Now just give everyone a bit of information at the start. Please watch this video to the end. There's a few really important points I need to make with the red question at the end there, and it's going to go a long way in helping you understand how it all works. So firstly, with recurrence relations, they all use a specific rule. If you ever see that word recurrence relation, which we see here in the green question, recurrence relation, you must use this rule. Okay, and it must be formatted exactly like this. It starts with T0 equals. T0 means the first number in the sequence. Okay, so T0, the first number in the sequence. Then we put a comma, and then we write the next term, which is written like this: Tn plus 1. Because Tn is the current term, Tn plus 1, so Tn1, is the next term. The next term is the same as, equal to, the current term, because Tn's the current term, the current number in the sequence. Tn plus 1 is one more after that, so the next term. The next term is the same as the current term, except here you need to write what's happening each time. Alright, so to see this in action, this is our first sequence for the green one here. We're going to write a recurrence relation for each. So just like above, we write the first term is number 2. First term is number 2. Nice and easy. Comma. The next term is equal to the current term, but what's happening each time here? Each time they are going up by 2. So it's plus 2, plus 2, plus 2, you get the gist. I'm not going to do that for every question. So it's the same as the current term, plus 2. So if you're looking at, and just to explain how the rule works, the first term 0, easy enough. The next term is the same as the current term, plus 2. So it doesn't matter if this term here, or this term here, is 1,000. The term after it is still going to be 1,000. It's just going to be 1,000 plus 2. So it's plus 2 each time. All right, let's keep going. Next question. Green B. The first term is 35. The next term, Tn plus 1, is the same as the current term, except we're minusing 5 each time, because you look at the difference from each one. Minus 5, etc. You're all pretty good with patterns. I'm sure you can work that out yourselves. All right, over to this one. This one's a bit more complicated. So the trick to this is asking yourself what's happening between each number here. We've got a 2 turning into a 6. All right, so that's going to be a difference of 4. So is it plus 4 each time? It is not plus 4 each time, because a 6 goes into an 18 then. If you've got numbers that are substantially increasing by different amounts, chances are it's being multiplied by something. Okay, it just comes down to how well you can read a recursion, really, and a pattern. So what can we multiply 2 by? Sometimes they're going down as division. Sometimes it can be multiplying and then adding a number. There's so many different variations it can be. It's just a bit of a practice makes perfect situation. All right, a 2 to a 6. If we times 2 by 3, it equals 6. And then if we times 6 by 3, it's 18. 18 by 3 is 54. So we get the rule there. The rule is times 3 each time. So the first term is 2. The next term, Tn plus 1, is the same as the current term times 3. You can technically also write this as 3 Tn, 3 times the next term, but in all honesty, most of the answers I tend to look at have Tn times 3. So yeah, I just stick with what most of the answers look like, which is this way here. All right, now we're writing we're writing sequences based on recurrence relations, literally the opposite of what we just did. So it's just a matter of reading these and understanding what they mean. So the first one here, the first term is 1. So we start with 1. And then we literally just focus on what's happening at the end here, Tn plus 3. It's just saying add 3 each time. You're doing the first 5 numbers there. Okay, so first 5 numbers, we are doing plus 3. So that would be 4, 7, 10, and 13. So that's going to be our answers just there. Okay, next one. T0 is 13. The starting term is 13. The next term is the same as the current term, times 2. So we've got here 13, 26, 52, 104, 208. All right, so you can see there, it just keeps doubling. All right, nice and simple. Last one. Starting term is 64. The next term is the same as 14 minus the current term. All right, so this is how we work this one out. And this is a really good one to do from scratch, because when you see patterns like this, you'll instantly know what its recurrence relation is going to be from now on. It's just a matter of experiencing these things and seeing how they work, and then you'll just know for next time. That's why these videos can be really helpful with this. All right, so we start at 64. And we've got to write the next 5 numbers, but it's going to be 14 minus the current term. So if the current term's 64, here it's going to be 14 minus 64, which gives us negative 50. So this one here is negative 50. Next term. The next term is going to be minus 50, and then it's going to be 14 minus 50. So 14 minus minus 50. Because remember, it's 14 take away, then minus 50. And it's important to look at here, you've got a double negative. 2 negatives make a positive. So it's 14 plus 50. It goes back to 64. And you can see the pattern here. 64 minus 50. 64 minus 50. It just keeps going like that. So if you ever see recurrence relations which sort of yo-yo like this, 64 minus 50, 64, it's usually going to be a number take away that previous or current term. That's how it works. All right, now over to an important one, which is red. And I better change my colors here just so we can get a nice clear view. We need to find T13. All right, that's the 13th term in this sequence. And this is where it is a lot trickier than what it might lead on to be. All right, I'll just check how I'm going for time with this recording. Yeah, we're good. All right, so we've got the first 5 here. We need to write the recurrence relation first of all. So let's do that one really quickly. It's going to be T0 is 3. The next term, Tn plus 1, is the same as the current term, but what? What's happening here each time? We got a 3 to a 7. So could it be plus 4? I think not, because if we add 4 to 7, it does not make 15. So again, now we check for multiples. What can we times 3 by to make 7? That kind of doesn't work, because 3 times 2 is 6 and 3 times 3 is 9. If you ever get to this situation, my advice is check multiples and then addition or subtraction. So we can times 3 by 2 to get 6, then add 1 to get 7. Does it work for here? 7 times 2 is 14. 14 plus 1 is 15. So that would be our rule. It would be times 2 plus 1 each time. Now for this, we need to find term number 13. This is where most people go wrong. Now I have done this in advance, and how would you do it? Well, if you get your CAS handy, and apologies because I actually don't have the CAS software on my home PC, what you do is you do the first term, so you literally put into your CAS 3, and I'll write this as I'm saying it. You just do 3 times 2 plus 1, and then you press EXE, which is your answer button. And then it's going to come up with lovely number 7. Then if you literally don't press anything else and instantly press times 2 plus 1 again, then press EXE, what it does is it uses it replaces the 7 and uses ANS. That stands for the answer. The answer to this, times 2 plus 1. Now every time you press EXE after this, it automatically does that rule. So you literally, it seems silly, you just keep pressing EXE. You just count in your head how many times you're pressing it till you get to term 13. All right. Now, something to be aware for. There's a bit of a trap with this question. See how it's T13? I'll try and get through this quickly because I'm running out of time. 127 is your next one. 255 and so on and so forth. 255, 511, 1023, 2047, 4095, 8191, 16,383, 32,767. Here's where most people go wrong. They look at term 1, 2, 3, 4, and so on. This is not term 1. The first term is T0, so it's 0. Technically, you're finding the 14th term. So the answer, will be there.